All matter is made up of tiny particles called atoms, each consisting of positively charged nucleus with negatively charged electron moving around it. Charge is measured in units called coulombs. It is denoted by a capital C. The charge on an electron is negative 1.6 times 10 to minus 19 coulombs. Normally, atoms have equal numbers of positive and negative charges so that their overall charge is zero. But for some atoms, it is relatively easy to remove an electron, leaving an atom with an unbalanced number of positive charges. This is called a positive ion. Proton and neutron reside in nucleus. Charge on a proton is positive 1.6 times 10 to minus 19 coulombs. Charge on a neutron is 0. So, nucleus is positively charged. The mass of a proton is 1.67 times 10 to minus 27 kilogram, whereas the mass on neutron is 1.674 times 10 to minus 27 kilogram. The mass of electron is 9.1 times 10 to minus 31 kilogram. In 1912, Robert Millikan performed an experiment to determine the charge on an electron using charged oil droplets. The experimental results show that no matter what the charge on the droplet, it seemed to occur only in integral multiple of elementary charge E. The charge on an electron, that is negative 1.6 times 10 to minus 19 coulombs. The conclusion was that charge is not continuous but quantized or exists only in discrete amounts. Atoms in metals have one or more electrons which are not held tightly to the nucleus. These free or mobile electrons wander at random throughout the metal. However, when a battery is connected across the ends of the metal, these free electrons drift towards the positive terminal of the battery, producing an electric current. The size of the electric current is given by the rate of flow of charge. Electric current is an SI base quantity. The SI base unit of current is the ampere, or AMP for short, with symbol A, capital A. The SI unit of all other electrical quantities are derived from the SI base unit. For example, a current of 3 amperes means that 3 coulombs pass a point in a circuit every second. In 5 seconds, a total charge of 15 coulomb will pass the point. Charge is equal to current multiplied by time, or it is written as Q is equal to IT, where the charge Q is in coulombs, where the current I is in amperes, and the time T is in seconds. The coulomb is that charge passing a point in a circle where there is current of 1 ampere for 1 second.